5.4, equivalent functions of angles. Expressed as a function of a different angle between 0 and 360 degrees. This goes back to those reference angles and finding an angle with that common reference angle in each quadrant. That's exactly what we're doing. So let's think of sine of 237 degrees. What quadrant would that be in? Remember, this is 0 to 90 to 180 to 270, so it would be somewhere here in quadrant 3. It doesn't matter where you make it. Let's just make it like this. I want to find that reference angle. So this was 237. When you're in quadrant 3, you're past the 180. So to find what this is, you want to take 237 minus 180. And that tells me my reference angle, or this angle here, is really 57 degrees. So I'm going to put reference angle is 57 degrees. Okay, so you've got to think about sine in quadrant 3. Sine is, since it's y, it's going to be negative. So it's negative here. What other quadrant would it be negative in? Well, where is y also negative would be here in quadrant 4. And so I'm trying to make an angle here that's also 57 degrees away from the x-axis. Okay, and then we need to figure out what is the actual angle here. If I were to go all the way around, what is this? To find what it is in quadrant 4, you would have to take 360 minus the 57, because we're not quite all the way around to 360. And that would be a 303. So we could write this as sine of 303 degrees. Okay. The other thing you could do to check is put in sine of 237. See what decimal it gets. See how it's negative 0.83867, on and on and on. And then check what we just came up with, sine of 303. And see how it's the exact same thing. What's going to happen to tell you you're wrong, let's say you would have said, okay, my reference angle is 57, so that's my answer. Sine, where'd you go? Sine of 57 degrees is almost the same, but it's positive, right? Because we talked about sine's positive when it's in quadrants 1 and 2. So you're finding the quadrant where it will have the same positive negative value and then finding what that angle is. Okay, so number 2, cosine of 136. Think about where that's at. 136 would be somewhere in here, right? Okay, so I would have to find the reference angle. And so to do that, since this is a 180 and I'm not quite there, I would take 180 minus 136, which is 44 degrees. Okay, cosine in quadrant 2, since it's an x value and I'm going back, that's a negative. So I have to think of where else is cosine negative. Where else would an x value be negative? That would be here in quadrant 3. So I want another 44 degree reference angle here. What would this actual measure be if I went all the way from standard position open to here? That would be 180 plus 44, which is 224. So I could rewrite this as cosine of 224 degrees. And again, you could check, plug in this on your calculator and this, and see if you get both negative values. All right, last one is tangent. 353, that is almost to a 360, so I didn't really do that justice, but a little closer. So what is our reference angle, right? To find it, we would do 360 minus 353, which is 7 degrees. Okay, so then I need to figure out what is tangent in this quadrant. Tangent in quadrant 4, we have a positive x but a negative y in quadrant 4, so that would come out negative. I need the other quadrant where tangent is negative, which would be the diagonal, so it would be somewhere here. I need this to be a 7 degree reference angle, so what is this angle all the way to here? That would be 180 minus 7. which would be 173 degrees, so it'd be tangent of 173. And that's it.